want to be able to determine whether two functions are inverses of each other. And here's the definition of um, inverse relation among functions. It's that if f of g of x is equal to x and g of f of x is equal to x, then they are inverses. Now, the larger implication of an inverse function is that one function undoes the other function. The inverse is an opposite action. So, I want to look at these various functions and give you the process of finding the composition, but then also explain it in words. So for part A, I have that f, of g of x. Remember, this is the same thing as just f of g, and that is equal to 2g plus 3. And now we substitute in what g actually is. So this is 2x plus 3 over 2, right? That's what g is, plus 3. Now these 2's just cancel, and that gives me x plus 3, which is x plus 6. That is not x, and so these are not inverses of each other. I am going to find g of f of x because I'm required to by the system. So g of f is equal to f plus 3 divided by 2. But f is 2x plus 3, and then plus 3 divided by 2. Right, this right here is f. That is 2x plus 6 divided by 2, which is x plus 3. Not inverses. I want to note here what f and g actually are. F is the function begin with x, multiply by 2, and then add 3. The inverse of x, which is notated this way, would be this. Begin with x. And now I'm going to undo this action. Subtract 3. And now I'm going to undo this action. Divide by 2. So f inverse would be this. X minus 3 divided by 2. So we can see the little trick they put in here. Instead of subtracting 3, they added 3. Now I want to look at part B. I have f of x is x over 2 and g of x is 2x. So let me rewrite that right down here. F of x is x over 2 and g of x is 2x. Note that for f, we begin with x and we divide by 2. And for g, we begin with x and we multiply by 2. These two are inverses. They are opposite actions. So f of g of x is, well, let me see. It's just g over 2, right? That's 2x over 2, which is x. G of f of x is 2 times x over 2, and that is just x. These two are inverses. I also want to say that this will always hold. If f of g of x is x, then g of f of x will also be x. Sometimes when we're dealing with fractions or more complicated functions, one direction is easier to test than the other. So you do want to always test both, especially if you come out with something that's close but no cigar. I've never seen an algebra textbook that admits that you really only need one of these. But I think the reason that you're required to do both is because in more complicated functions, sometimes one is easier than the other. And so you need to know how to do both.